light and heat through nuclear fusion, a process where atomic nuclei are combined to form heavier elements, releasing enormous amounts of energy. The stars are born in vast clouds of gas and dust called nebulae. Under the force of gravity, these clouds begin to collapse, causing the material to compress and heat up. Eventually, the core of the collapsing cloud becomes so hot and dense that nuclear fusion ignites and a star is born. Stars spend the majority of their lives in what's called the main sequence phase, during which they fuse hydrogen into helium in their cores. The exact life cycle of a star depends largely on its mass. Small stars like red dwarfs can burn for billions of years, while massive stars burn through their fuel much, much faster. As a star ages, it eventually runs out of hydrogen in its core and begins fusing heavier elements, causing the outer layers to expand. For stars like our Sun, this expansion will lead to the creation of a red giant. Once nuclear fusion stops, the star sheds its outer layers, leaving behind a dense core known as a white dwarf. But for stars that are much larger than our Sun, the story is more violent, as you'll recall. Massive stars undergo a catastrophic collapse when they run out of their nuclear fuel, resulting in a supernova explosion. This explosion scatters heavy elements across the galaxy, enriching the interstellar medium with building blocks for new stars, planets, and even life. The remnant of a supernova can either be a neutron star, or, if the star was massive enough, a black hole, a region of space-time so dense that not even light can escape its gravitational pull. In the grander context, the stars themselves are only small components of much larger systems. The universe is expanding, a fact discovered by Edwin Hubble in the early 20th century. Observations of distant galaxies revealed that they're moving away from us, with more distant galaxies receding faster than those nearby. This led to the understanding that the universe itself is expanding, with space stretching over time. The expansion of the universe traces back to a singular event known as the Big Bang, which occurred roughly 13.8 billion years ago. The Big Bang marks the beginning of the universe, when all matter, energy, and space-time were condensed into a single point of infinite density before rapidly expanding and cooling. The expanding universe has profound implications for astrophysics. As space stretches, the light from distant galaxies is also stretched, a phenomenon known as redshift. This is one of the key pieces of evidence for the Big Bang and the ongoing expansion of the universe. As space expands, the galaxies themselves move farther apart, creating a large-scale structure in the universe. But even though galaxies are moving away from each other, they're also bound to clusters and superclusters by gravity. One of the greatest mysteries in astrophysics today is the nature of dark matter. Though we can observe the effects of dark matter, we still don't know exactly what it is. Dark matter makes up about 85% of the matter in the universe, but it plays an essential role in the formation of cosmic structures. Without dark matter's gravitational influence, galaxies and clusters of galaxies would not have formed as they did after the Big Bang. Its presence shaped the large-scale structure of the universe. This brings us to the concept of the cosmic web, the vast interconnected network of matter that makes up the large-scale structure of the universe. The cosmic web is a complex filamentary structure consisting of galaxies, clusters of galaxies, and vast voids. These filaments are formed by the gravitational pull of dark matter, which acts as the framework around which galaxies form and evolve. In this sense, dark matter is the scaffolding of the universe, guiding the formation of galaxies and clusters along its filaments. The cosmic web isn't static. It evolves over time as galaxies move through it, merging, forming new structures, and sometimes being torn apart by gravitational forces. Studying the cosmic web allows astrophysicists to understand the distribution of matter in the universe, the role of dark matter, and how galaxies evolve in different environments. Another profound mystery in astrophysics is the existence of dark energy. If dark matter governs the structure of the universe, dark energy governs its expansion. Observations of distant supernovae have shown the expansion of the universe is not just continuing, it's accelerating. This acceleration can't be explained by gravity alone, suggesting the presence of a repulsive force or dark energy that's driving galaxies apart at an ever-increasing rate. Dark energy is even more enigmatic than dark matter, and understanding its nature is one of the most significant challenges in modern astrophysics. The interplay between dark matter, dark energy, and visible matter gives rise to the universe as we know it, a vast, dynamic, and ever-expanding entity. Astrophysics seeks to uncover the laws that govern this interplay, from the smallest particles to the largest structures in the cosmos. As we come to the close of our journey through the basics of astrophysics, we're left with a deeper appreciation for the complexity and grandeur of the universe. The universe is a place of extreme forces, immense distances, and profound mysteries. From the life cycles of stars to the gravitational pull of dark matter, and from the expanding universe to the cosmic web, astrophysics teaches us that the universe is governed by a set of fundamental principles that apply everywhere, from the smallest particles to the largest galaxies. But there is so much that we don't yet understand about dark matter, dark energy, black holes, and the ultimate fate of the universe itself. Astrophysics isn't just the study of celestial bodies, but the study of the very fabric of reality. It challenges us to look beyond our earthly perspective and to understand our place in the cosmos. It reminds us that while we're small in the grand scheme of things, we're also part of something much larger.